lesson 2.3, one-sided limits. And here we have the function f as x approaches the square root of x. So in other words, f of x equal to the square root of x is continuous for all x that's positive. Since the square root of 0 equals 0, it is clear that the function f of x, as it tends towards f of 0, as x tends to 0 through a positive value, so that in other words, as the y values tend toward f of x tends towards f of 0, then as x tends towards the x values, x tends towards 0 through positive values. Since it is not defined for negative values of x, the definition of continuity is given in section 2.1 is not filled at x equals 0 because it does not approach from the right and the left. So if we look at a graph of the square root, we're looking at f of x equals to the square root of x. Okay, and we're looking at 0, right? We can't say that you have a limit as it approaches from the right and the left. So we can't use that definition of 2.1 here. So we have to use a one-sided limit. So that's where we can say, all right, as x approaches in this case, 0 from the right, then we can identify the limit. Is not filled at x equals 0. We now extend the definition of continuous functions so that the function such that the square root of x will have the natural property of continuity at the endpoint of its domain. For this purpose, we will need the concept of a one-sided limit. So we will be looking a lot at the endpoints of our limits. Okay, we have a definition here. Suppose that function f is a function from a domain, we'll call it D, in all real numbers to all real numbers. In other words, all real numbers coming into the function, all real numbers coming out of the function. And that's in domain D. The function f tends to our limit L as x tends to A from the right. So in other words, we have our limit of f of x as x approaches A from the right will equal to our limit if, in first case, there is an open interval I in domain D that has A, this A here as x approaches A, as its left endpoint. So this would be our left endpoint here for our square root of x. And the second condition for each epsilon greater than 0, there exists a delta greater than 0. So in other words, are we going to achieve a limit for our function f of x minus L is less than epsilon whenever x minus A is less than delta but greater than 0. If f tends to our limit L as x tends to A, as x tends to A, f of x tends to our limit from the right, we would write this as f tends to our limit as x tends to A from the right. We denote the limit f of x equal to x as x approaches A from the right. A similar definition is employed with limits from the left. In this case, the condition x minus A is less than delta is replaced by a minus x, because now at the left, if you're looking at this, and this is a, and here's your limit here. Oops. Okay, here's your function, right? F, and this is a as x approaches a. Well, this would be from the left, but here you have a plus delta and a minus delta is, here you have L plus epsilon, and this would be L minus epsilon. So as here, because you're approaching the limit from the left, then you're going to be using a minus delta. So that's where we get to x, a minus x, and so the similar definition is employed in limits from the left. So going from the left, in this case, the condition x minus a is replaced by a minus x. So as it approaches from the left, you use a minus x. Well, because they're absolute values, they're going to be the same, right? So if you were to subtract, so in that case, in the notation for f of x as approaches L, as x approaches a from the left, then you have the limit of f of x equal to your limit as x approaches a from the left. Okay, so let's look at down here. Definitions. A function f is continuous on the right is at a if a is the domain, is in the domain of f. So a has to be in the domain, right, for f. If it's not, then you can't use it. As f of x approaches f of a, so in other words, as we're putting in our limit, our a, our value a, and getting our limit as x approaches a, the function f is continuous on the left at a if a is in the domain. So a has to be in the domain. Okay, and we're going to identify that in a moment. All right, so we're going to stop here and take a look at some problems.